Question from electrostatic and electromagnetic part, magnetic part from the electrical engineering paper. Okay, so let us try to solve this. So what it is saying is there are 3-point charges placed at charges are Q, Q and alpha Q located in free space at -1, 0, 0, 1, 0, 0 and 0, -1, 0 respectively. You have to find out the value of alpha for which the electric field to be 0 at one specific point. So let us draw the point first where these points are located, and then we can comment on the calculation of the electric field. So let's say this is y-axis, this is x-axis. And you see in all the points 0, z is 0, z is 0, z is 0. So it is in the z plane. So I can take only x and even in the point which is desired, they're also z equal to 0. So we can take only x and y plane, right? So let's say this is x-axis and this one is y-axis. So my one point is -1, 0, 0. So let that point be here. Other point is at 1, 0, 0. So this one is here. So this is 1, 0, 0. This one is -1, 0, 0. And one point is 0, -1, 0. So that point will be here. 0, -1, 0. Okay. So this charge placed here is Q. Charge placed here is Q. And the charge placed here is alpha Q. And we have to determine the field at 0, y. We have to define field at this point. So this is 0, 0 0.5. Okay. So let us see how the field lines will be. So this the electric field due to between this is positive, and the electric field line should be in this direction, right, at this point. Due to this, in this direction, right. Resultant of this will be in this direction. So let's say this is E. This is also same as E because charges are same. So resultant is going to be, now what is the angle between this? Let's say this angle is theta. Let's say this angle is theta. This will be theta, then this is also equal to theta. This is also equal to theta. And we can determine this theta. So this is also same theta. So this is going to be 2e cos theta. Okay, this is one thing. Now to make this field 0, this should be negative charge. Okay, so let's say this vector may be some electric field E, and we have to determine that the net sum of electric field here at this point is equal to 0. So let me write here the net electric field E is E1 vector plus E2 vector plus E3 vector. E1 is due to Q charge, this is due to Q charge, this one is alpha Q charge, right? So Q and Q, they both will be same, distance are same, so this I can written as 2 times of E1 plus E3. So what is E1? So this E1, which is we can calculate now here. E is 1 upon 4 pi epsilon naught Q divided by what is the distance? This one is 1, this one is 0 0.5, so this will become 1 plus 0 0.5 whole square, so that is 1.25, right? And what about this? This is E here, and the cos theta will become, so E cos theta is going to be 1 upon 4 pi epsilon naught Q upon 1.25 cos theta. So cos theta is again 0.5. Uh, Sorry, this will not be cos theta. This will be sin theta here. Mistake here. This is line. This one is theta. This one will become. So it is not cos theta. Let me just correct this because I have taken the angle rotation differently. And theta and theta. That is 1 upon 4 pi epsilon. Please recheck it once again. This one is 1. So sin theta is, what about this angle? This angle is, if E is in this direction, uh, yeah, this angle will be 90 minus theta. That also will be 90 minus theta. Right. So 90 minus, this will not be theta, this will be 90 minus theta. Just write again. So it will come 90 minus. So this is cos of 90 minus theta, that will become 2e sin theta. So this is q upon 1.25 into 0.5 divided by root of 1.25. Okay, so this is e sin theta. So that can be substituted here. So this is going to be 2e um, 2e sin theta plus e3. Now what is e3? Now this I can write it as 2 times 1 upon 4 pi epsilon naught. That is straight line. There is no angle in that. In E3, q upon 1.25 into 0.5 upon root of 1.25. Right? This is done. And next one is same 1 upon 4 pi epsilon naught alpha q divided by this is going to be, this one is 1, this one is 0.5, so this is 1.5 whole square. And the net result of this must be equal to 0 because the resultant electric field at this point must be 0. So we can simplify this further. This one will be 2 q 0.5, 1.45 not can be cancelled. 1.25 into root of 1.25 plus alpha q upon 1.5 is 2.25. 2.25 that is equal to 0. So given this is 0 and we have to find out alpha. So it is 2 into 0.5 is 1. So this implies alpha is equal to minus 2.25 divided by 1.25 root of 1.25. So this if you solve 1.25 root is around 1.11. So it is minus 2.25. 1.25 into 1.11. If we solve using, if we take the calculator and solve it, we get around 1.609 or equivalently it is up to the round up to one decimal place. 1.6 is the right answer. Minus 1.6. It has to be negative sign, right? So answer is minus. So in case if you are getting positive answer, be careful because if it's positive, then net electric field will never be 0. So to make it 0, it has to be negative. 12.5 minus 1.6. This is the end of question from electrostatics from the electrical engineering paper. Magnetic, actually this is question related to the, what do you say, mm, divergence. Actually, we need to find out the value of P and we have to make use of divergence here. So it is a vector calculus part that comes into picture here. So let's see how we can solve this question. So there is a magnetic field is given and that is represented as in terms of in spherical coordinate system. H r comma theta comma phi given as 1 by r cube p cos theta r vector and sin theta theta vector. Phi vector is not there. Okay, phi vector is not there. So to find out the value of p, we can make use of that Maxwell's second equation, or I do not know whether in the electrical that equation is there in the part of the syllabus. Del dot b equal to 0, del dot h equal to 0. Right, that's one. Now to find out the divergence in the spherical coordinate system, the expression for divergence in spherical coordinate system is given by 1 by r square del over del r square Vr plus 1 by r sin theta del over del theta v theta sin theta plus 1 by r sin theta del over del phi v phi. So here, since v phi is not given, so this component directly goes out. So Vr and v theta are given. Vr is p cos theta and v theta is sin theta. So let us substitute that. So that will become 1 by r square del over del r. Now Vr is p cos theta by r cube. So that becomes r square 1 by r cube p cos theta. Okay. Plus 1 by r sin theta del over del theta. V theta is sin theta. That will become sin square theta. Right? This is equal to 0. So let us find out this. So that becomes 1 by r square. And this is 1 by r will get cancelled when we find the derivative of this. This will be minus 1 by r square p cos theta. Okay. And this side is 1 by r sin theta. And v theta, oh sorry, v theta is upon r cube is also there because this r cube is there. So that will be 1 by r cube 2 sin theta cos theta is equal to 0. So 1 by r square here, 1 by r square here, that we go this side becomes 0. Now we are left with minus p cos theta plus 2 cos theta sin theta equal to 0. And sin theta is below here, that sin theta will get cancelled. This one will cancel with this. So this will be p cos theta is equal to 2 cos theta. Theta is cancelled. P equal to 2. So that is the answer for the question from electrostatic part. Actually, here the electrostatic I should not say because the electric field is changing with space, or magnetic field. Sorry, magnetic field is not constant. So answer for this is 2. That's the end of question from the EMF field from electrical imaging paper.